Hello and welcome back to Waveform Science. I'm sitting on the floor of the test lab tonight because we're going to be taking a look at Bluetti's EP500Pro. This 185-pound unit is not going up on the table, so we're going to be doing all the tests on the floor next to the table. The unit itself is squarely in Bluetti's small home, apartment, condo, part of a whole house backup unit, in that it's got a 3 kilowatt inverter, definitely big enough to hook up to a transfer panel. It's got the ability to hook two of them together for split phase. It's got 5 kilowatt hours of battery per unit, so definitely enough where if you split phase two of them together, the average house tends to use between 10 and 20 kilowatt hours of power a day. So two of these hooked together is 10 kilowatt hours, so that's in the low end of the range, but still absolutely good for emergency use cases, backups or power leveling, using less power when the power costs more. So we're going to take some time and go through all the features of this. So first off, what does it have in it? Of course, I already covered the inverter size and the battery size. What else does it have? Both Wi-Fi and Bluetooth app control. And the main selling point of this over, say, the AC300 or the AC500 is actually going to be the form factor. Let's take a look at that first. The closest competition model to the EP500Pro would be the either AC300 or AC500. In this case, I have an AC500 sitting here that is normally what runs the solar generator testing lab, which of course is offline right now because I have my power source disconnected to run this particular segment. So the AC500 is modular. Each piece is less than 100 pounds, which means if you had to carry it upstairs and you had two people, you could do it. Not saying it's easy for one person to do it, but with two people, it's definitely can be done. EP500 Pro, on the other hand, is 185 pounds, single unit. You need a furniture dolly to move it up and down stairs. That being said, on a single-story building or something with a nice wood floor, the EP500 Pro is much easier to move around, being that it has wheels on it. One additional form factor advantage for the EP500 Pro over the AC500 is this. The EP500 Pro can fit between the chair and the wall. AC500, not so much. So what does EP500 Pro come with in the box? First off, of course, there's the EP500 Pro itself. Then there's the AC charging cord. This comes in there. This is a Weepu SB29 to NEMA 515 plug. Standard house outlet. This will let you charge at 12 amps safely off a 15 amp plug or 16 amps off a 20 amp plug safely. Next, it comes, of course, with the solar cable. Gives you two pairs of MC4 connectors and then another Weepu connector to go into the device itself. It comes with a car charger cable that you'll notice I haven't even taken the zip tie off of. It would take darn near forever to recharge this thing off a car, especially given that the actual charge rate, because of the standby power that's in here, uses 40 watts just to stay on. So when it's only pulling 100 watts from a car, it's going to only really be charging at 60 watts, and it's a 5,000 watt battery. So do the math there. Yeah, it's going to take you forever in a day. So I don't recommend using the car charging cord cable. What does it not come with that you're probably going to want? The RV connection cable. This gives you a 12 volt 30 amp output. Very handy for running RVs and other 12 volt devices. Does not come in the box, not all that expensive, but you're probably going to want one of these. The other one that's kind of not in the box but is desirable would be a bigger charging cable. This one is a 30 amp TT30 cable. Bluetti has these on its site. Or there's also a 30 amp L1430, I think, cable. Those are both available on their site. And there's also the 50 amp cable that goes along with the AC500. Right here, this is a big beefy cable. This one's honestly overkill. It won't charge fast enough to need this, but if you happen to have this outlet, the 50 amp outlet that you're going to plug it into, it will charge off this. The connector fits. It's obviously not going to charge to 50 amps. It's limited to 30 amps. But I do recommend with a battery size this large, you definitely are probably going to want to charge faster than the 12 amps that you can charge off of at a regular plug. In fact, much of my testing was done with this cable right here, running off the output of my AC500 to recharge it. So what does it weigh? Instruction manual says 183 pounds. I do have scales that will read that amount of weight, but I don't have a good way to stabilize the EP500Pro to put it on the scale in such a way that I'm not worried that it's going to fall off. So we're just going to trust that the weight is in fact correct from the manufacturer here. Additionally, it's a very heavy unit. It ships on a pallet. You're going to need 2 people to get it off the pallet because it's 183 pounds and most people can't pick that up on its own. It does have, very helpfully, a handle here and another on the back to help you pick it up, so it's not a straight side surface. Bluetti did think about the fact that we're going to have to pick this up at least once to get it off the pallet. The other thing to note is that it is relatively skinny and it is relatively tall. Here it is straight from the front. So if you were to put a significant impact on this from the side, you could potentially knock it over. They have put a warning label on the top of it to warn you not to have children unattended around the device. I can imagine a 4-year-old knocking this over. So just be aware. So keep it in a place where you'd keep other, heavy, fragile items away from children. As far as energy density by weight, it fares fairly well. I'm just going to compare it to 2 other Bluetti devices in the same battery class. First off, an AC300 with either 1 or 2 batteries. And the reason I've got 1 or 2 is because 1 battery for an AC300 is less capacity. We're talking 3 kilowatt hours instead of 5 kilowatt hours on the EP500Pro, where 2 batteries is 6 kilowatt hours, which is bigger in capacity than the EP500Pro. So really the only fair thing is to look at both. Energy density by weight on that, either 24 or 29, AC500 either 20 or 26. The battery on the for the AC500 is a couple of inches taller for the battery versus the B300. So EP500Pro actually fares really well. You wind up needing to get into a multi-battery system before you wind up having similar levels of energy density. And it's sleek and it looks very nice. Kind of the downside to this, of course, is that you can't expand it, but it's already big enough for almost everybody who lives in an apartment on its own. So it looks nice and you can't expand it, but it does look nice and you don't need to expand it. So maybe that's not a bad trade-off. EP500Pro external dimensions. Tape measure says we're looking at about 22-ish by height to the floor, by the way. So including the wheels here, about 30-ish. And if we rotate this 90 degrees and look at just the front, we are at right around 11-ish. Manufacturer says we are looking at 22.8 by 11.8 by 29.9, right about what I measured. 4.7 cubic feet of volume. So not a very small power station, but it is on wheels, and as you see, it's pretty easy to move around on a flat surface. Energy density by volume, again, I'm comparing it to the AC300 and the AC500, both with 1 and 2 batteries. The 2 battery systems tend to be more dense by volume, and the 1 battery systems tend to be less dense by volume. So kind of in the middle there. One thing to note, though, is that this is not the octopus that is the AC500 and the AC300 with a whole bunch of cables flowing everywhere in kind of a mess. This is something that actually, I can see my grandmother have this in her living room. Let's take a quick look at the controls here first, and then we'll go into depth on each particular of the ports. So on the top, we've got 2 wireless charging pads. We also have a door that opens up, and inside the door, you have the various DC outputs, including, by the way, the 30 amp output. Below the door, you have the screen and the main power button. Nice silver power button, similar to other Bluetti devices. You've got some fans on the front. You've got, of course, the handle I referred to earlier. You've got the AC outputs, also, interestingly, on the front. So if you're going to plug something in, you plug it into the front of it. including a 30 amp RV slot. Very nice there. Input port is down here also on the front. Push the button to get that to open, and you've got the same airline style connectors that Bluetti uses on the AC300 and the AC500. By the way, exactly the same cables used on the AC300 and AC500. And that's the ports on the front. The left side of the device has a Bluetti logo on it and the model number and nothing else. There's no controls on here at all. The back of the device has... Oh, by the way, if you didn't notice, the rear wheels rotate. The front wheels don't, so you kind of have to jiggle it. The back of the device has a fan port, it has your sticker, and it has your master power-off switch. If you flip this off, it actually disconnects the BMS from the rest of the system and then allows it to be stored for a little bit longer if you're not going to use it. Also has a grounding lug back here. Other side of the device, you have a big Bluetti logo on it, and nothing, no controls. So all of your input and output ports, going back to the back for a minute here, all of the input and output ports are on the front. The back has another handle to help you pick it up, and has a master power off switch, but that's it. So if you're going to be plugging this into the AC wall outlet in order to leave it charging, and let's say you have it in your living room or something, you are going to have some cables coming out of the front down here, because that's where those cables actually are. DC output port testing. We are looking down at the device from above. Starting at the back of the device, we have two wireless charging pads, and of course they both work at a full 15 watts. Moving down the device a little further toward the front, we have a door labeled DC output. Etched on it is the word open. If you push on the open, the door pops open, and behind it you have a bunch of DC ports. First off, over here you have a 12 volt 30 amp port, which is, by the way, the same port you'd find on an AC200 Max or an AC300 or an AC500 that's got 30 amp port. By the way, uses the same cable, and by the way, doesn't come with the cable in the box. The test unit didn't either, but I happen to have the cable from my AC200 Max, so I used it from there. The port, of course, does work as intended, and you can pull a full 30 amps from the port. Next, cigarette lighter port right here. Of course, I have one of those. These are rated for 10 amps max, and you can, in fact, pull 10 amps from them. Next, we've got two DC 5521 barrel jacks. These are rated for 10 amps is what it says here, but it's actually 5 amps per connector. So you can pull, in fact, 5 amps from each of them simultaneously. But it's 10 amps for the circuit. Next, we have two USB-C ports, two of them. They are both 100 watt rated ports, as you can see. And you can pull 100 watts from them simultaneously. Next, we have moving to the bottom, we've got the blue ones, the USB-A quick charge ports, 18 watt ports. They do spec out as 18 watt ports. And you can pull 18 watts from both of them. Next, we've got the USB-A port, two of them. These are marked USB-A 5 volt 3 amp. They spec out as an extremely old standard for USB. I was kind of surprised when I saw this, actually. Most Bluetti devices at least spec out with the 2.4 standard. This is specking out with the 1.0 standard. What that means is potentially these are connected together internally. You can see here I have 1 meter hooked up to each of the two USB outputs. One here and one here. So 2 different meters. The first meter right now is pulling the full 15 watts that are rated for one of the ports. The second meter, as soon as I turn it on, the first meter cuts out. If I turn the second meter back off, the first meter turns back on. This is an old style USB-A port where there's actually only one controller behind the two ports, meaning it's not 15 watts per port, it's 15 watts for both ports. Let me demonstrate. If I turn this down to 2 amps, we go right around 2 amps. Now I can pull almost an amp from the other one before it shuts down. There we go. But if I pull more, it's going to shut down both meters. There we go. So it's actually 15 watts for both USB ports. It's a very old style design, basically meaning that if you want to recharge a cell phone, use one of these two ports to charge a phone. Don't try to use both, but that's why we've got the quick charge ports, which don't have this problem. Next, let's take a look at the control screen for the EP500Pro. If you've seen an AC300 or AC500 or AC200 Max, this is going to look very similar. So first off, they've got the big shiny button, which you push and turns it on. It comes up and you have a touch screen, similar to their other devices. So in the center, you have the current state of charge right there. You have whether or not there's any grid power coming in or AC load going out. You've got the solar, and if you tap on that, by the way, this will tell you the grid voltage, frequency, and hertz. The input frequency should be based on what country you're in. But you can actually tell if you're using a cheap generator and it won't charge because that number won't be right. Next load, you can see voltage, watch, and hertz, and the output state. Similar to what I covered in the AC500, it actually tells you whether or not it's using pass-through power or running off the battery here. We're going to have a specific video on just that coming up later. So next we've got solar input. We've got two solar controllers, just like the 300 and the 500, and I've got both voltage and power to display for both. Next I've got DC load. I have a total of 3 different output circuits. So we've got the 12 volt 10 amp output power. That is both the cigarette lighter port and the 5521 barrel jacks. Those are linked together. So that's 10 amps for those. We've got the 30 amp power output port, and then we've got the USB power delivery and wireless output. Those 3 different circuits for 12 volts. And they all turn on together. When you hit the DC button, they all turn on. Tells you the watts for each. Next, go into the settings menu, see what's down there. So first off, settings, we've got language settings. I can set it to English or Japanese if I want to. AC output voltage. There's the 100 volt for Japan setting and the 120 volt for the US setting. We've got 50 hertz or 60 hertz. If you're in the US, please always set it to 60 hertz. Don't change it. DC1 and DC2 input sources. We can either have PV, which I've got DC1 right now set to that. That stands for photovoltaic, which is your solar panels. Or we've got others, which is DC2. That's I have DC2 set to that, and you can set it back either way. When you do change this setting, though, you have to have nothing plugged in. So if you want to car charge this, which will, by the way, take a very long time, because it's a huge battery and it doesn't charge very fast off a car, you'd have to set it to other for the input that you're using. And then if you're using solar, you want to set it back to PV. So it kind of depends on how you have it set. Next, eco mode. You can turn it on or off. Tells you what it does there. Eco mode on this one will turn off the AC inverter after 4 hours of having a low load. That's all it does. It does not make the inverter run more efficiently. It does not make the device use less power. All it does is turn it off after 4 hours when the usage is low. Machine type, you can set single phase, or you can set split phase. Split phase being 2 of these linked together for 240 volts. Next, we have the working modes. These are your UPS modes. We have the same standard time control, PV priority, and customized UPS modes that are in other devices. Again, I'm going to put together a specific video on how the UPS modes work and what each of the settings do. So keep an eye out for that. We're not going to cover that in this video just because I'd rather do that in a separate standalone one. Okay. Silent mode. Silent mode does 2 things. 1, it makes it charge slower, and 2, it makes it charge quieter. You can actually do the same thing as silent mode by just setting the grid input current lower. Okay, max grid input current is basic mode and advanced mode. Basic mode lets you set it up to 50 amps. That's with the supplied power cable. The advanced mode, just like the other ones, requires a password that you're going to get from Bluetti. You have to contact their customer support, and they just want to make sure that you have the bigger power cable. They sell 2 30 amp power cables and a 50 amp power cable that will work. Those are the same ones that are used for the AC500 and the AC300. Same connector. And those will plug into a port that supports that much power. If you try to pull more than 12 amps from a 15 amp socket or 15 amps from a 20 amp socket, you're probably going to blow the fuse. US sockets are rated for 80% of their max capacity under constant use. So 15 amps, 80% of that is 12. 20 amps, 80% of that is 15. So don't go into the advanced menu unless you actually buy the proper charging cable, which I did and we tested and we'll show in a few minutes. PV parallel enable, same as the 300 and the 500. What this does is it puts both of the solar controllers in parallel and puts communication between the two of them so they can work together. So that's if you have one very large array and only want to run one set of cables. The catch is you have to be careful not to overload your MC4 connectors. Almost all MC4 connectors are only rated for 20 amps per connector. So you have to make sure that when you're going to use that, if you're going to run a single cable, be very, very careful to make sure that you don't overload your cabling. But you can use it, it's there. It'll save you running an extra cable if you use connectors that are rated for the amount of power you're running. Bluetooth, you can turn it on and off. That's to connect the amp. Wi-Fi, same thing. You can turn it on and off. One thing to note about the Wi-Fi here, it is 2.4 gigahertz only, and they are now starting to ship Wi-Fi access points that only have the 5.8 and the brand new, by the way, 6 gigahertz band in it, and no longer have 2.4. So be careful with your access point if you're going to replace it with a brand new one. Make sure if you get one of these that you still have the 2.4 band in there. Next, buzzer. That's just the beep. Turn it on, turn it off. It makes it make noise when the battery goes dead. That's pretty much all it does. Touch sound. If you turn it off, now it doesn't make any noise when you touch it. You can turn it on, whichever you prefer. Backlight brightness. You can set it brighter or dimmer. Up to you. Date and time setting. It fetches this off the internet, by the way. If you do connect to the internet, it'll set the clock automatically. Also figure out where you are. Sleep time, that sets how long the screen stays on. That has nothing to do with the device turning itself off automatically. That's simply the screen timeout. I have it set to never here, simply to make it easier to do recording. Restore factory settings, that's useful if you go in there and muck with the UPS settings and forget what you need to set it to, and you can set it back to normal. Next, after settings, we've got data. We've got the product info, got your serial number and your versions. Inverter and charge info. This is the same 4 buttons that you see on the main screen. The PV, which I already showed you. The grid input, which I already showed you. DC output, which I already showed you. And AC input, or AC output, excuse me, which I already showed you. Battery information gives you the battery voltage, the state of charge, and the battery state, whether or not it's charging or discharging or just sitting around not doing very much. I will call out that the standby state there. Right now, this device is not plugged into power, and the screen is on. So it is running from the battery. So it's going to continue showing standby until you're pulling over a certain amount of power from the battery. Because right now it is running off the battery and it's not showing discharging, it's showing standby. So just be aware of that. And next, alarm history. It'll show you what alarms have fired, what time they fired. You can scroll through them and you can clear them. And gives you the error code and what time it was when it fired. Very helpful little thing. And then we've got the alarm page, which has the same information as the alarm page that I just showed you. They just have it in 2 places. Next, we have the AC output max load test. So I have it sitting here. It's running off battery, no power plugged in. We're going to turn on some loads here. Second for the first one to kick on. There we go. Second set of loads. It brings it up actually a little bit over the maximum and then drops it back down. Handles that surge just fine. My startup surge on my device there. And on the screen it says I'm pulling 2800 watts. So let's slowly increase the power here until it overloads and shuts down. Let's see where the headroom is. 2800. We're at 2900, 3 kilowatts. So this is a 3 kilowatt rated inverter. 3.1, start to get an alarm firing. 3.2, 3.3, 3.4. Wow, that's pretty impressive. It's only rated for 3 kilowatts. 3.6. Where does it shut down? 3.8. 3.8. Alright, so I got 800 watts more than the rated maximum out of the inverter. Now, you can see I didn't get it for very long, but we did get the significantly more than the rating. Alright, AC maximum charge rate test. So you can see here that I don't have it plugged in right now. First, we're going to go in and check the settings. Go in here. I've got it set for 30 amps. So that's as fast as you can set it, and you need a password from Bluetti to do that, along with the cable, which is now plugged in. I'm going to go ahead and plug this in, by the way, to the output of my AC500, so I'm getting this kind of power. And let's see if it starts charging. Just found the grid input. And there we go. It's pulling a full 3 kilowatts. Actually, a tiny bit more. So that's pretty much exactly what it's rated to charge at, although I will note that 30 amps of charging at 120 volts is 3,600 watts. So that's actually more than the rating. The rating in the manual says 3,000 watts. However, the setting in the input state lets you set 30 amps, which is actually faster than it says it can charge in the manual. So I went ahead and tested this. The 30 amp setting and the 25 amp setting, by the way, 25 amps happens to be the same as 3,000 watts, is exactly the same, pretty much exactly the same curve. I asked them why they had it go up to 30 amps in the menu, given that 25 amps and 30 amps is exactly the same values. And what I was told is that the charge rate for 30 amps is set for Japan, where they only have 110 volts, and in order to get 3,000 volts, you actually need, or 3,000 watts, you need more amperage. So that's why they have that setting there. I also measured it at 15 amps, which is the most that you can get out of the stock cord through a 20 amp outlet, and that took 3 hours and 43 minutes to charge. I measured it at 12 amps, which is the max that you can get out of a 12 amp outlet, or excuse me, a 15 amp outlet. Because it's 80% of the maximum. That takes about 4 hours, 45 minutes to charge. And 25 and 30 amps is the same timing, roughly, plus or minus a little bit of fan, at about 2 hours and 20-ish minutes, 2 hours and 15 minutes for one run and 2 hours and 25 for the other, but effectively the same charge rate between those two. Solar charge rate measurements. So we've got the EP500Pro hooked up to my giant power supply, 5 kilowatt power supply. And we're going to simulate some solar and see how much solar it pulls at various voltages. Now the power supply itself is weighted for 33 amps. The EP500Pro is 12 amps per input, and I'm only hooked up to one of the two inputs, in this case PV number 2. It just happens to be the one that's hooked up. Both inputs are set to PV mode and PV parallels turned off. Let's go ahead and power up the power supply at 10 volts. Tap into PV here so it wakes up. There we go. We can see it's reading 10 volts, but it's pulling no power. Let's turn this up a little bit. 13 volts. Now it's in PV mode here. So it's in PV mode, not other mode. But it'll still charge, interestingly. If you had it plugged into a car and you accidentally left it in PV mode, it'll still charge. But at 100 watts, you're looking at something like 50 plus hours to charge this. So will it car charge? Yes. Is it practical? No. Not exactly something that I would suggest car charging a unit this large. But we're at 8 amps. Well, let's get up to 18. There we go. That's about a single solar panel, plus or minus. 148 watts. So very similar to other Bluettis, by the way. It's limiting itself to 8 amps of current right here. This is our current measurement. Below 30 volts. And you'll see when we get up higher 22 volts roughly. It's about your larger solar panels, 200 watters. We're charging at 175 watts. Again, still notice we're current limited to 8 amps, even though it's a 12 amp unit. Once we get up above 30 volts though, a little bit over 30 volts, yeah, 30.6 on this meter, we jump up to 12.2 amps. So something to consider, and this is true of all the larger Bluettis that I've tested. If you want to get full solar input out of this, you got to make sure you feed it more than 30 volts. Now, this is the larger Bluettis. They make smaller ones that only handle up to 28 volts. If you feed those 30 volts, you're going over the maximum. So do check your voltage. But if we're talking an EP500Pro in this case, or an AC200 Max, or a AC500, or an AC300, you're going to want to feed it 30 volts in order to max it out. So, and we're still only charging, by the way, at 363 watts because our voltage is too low. So let's get it up to about 50, 60 volts. That's your range of a single, there we go, 50 volts. That's your range of about the largest residential panels they make, single panel. And we're pulling 600 watts. So if you were to hook it up to a single 50 volt panel, most of them are not 12 amps. Most of them are more like 10 amps. But you can max out the panel, absolutely. Putting two in parallel, you're only going to get an extra 2 amps out of it. So again, you'd want to go in series and go up in voltage. So it's 1200 watts per controller. So let's see how high it takes to get to 1200 watts. The noise here, by the way, is my power supply warming up. There we go. Right around 100 volts is where we get to 1200 watts. And of course, we can go up to 150. That's the max. And you'll notice as I continue to go up that the current is going to start going down. See how my current is going down? That's because it's maxing out at 1200 watts for the charging. And I can go all the way up to 150 volts. And my current continues to go down as I go up in voltage. There we go. Now, when I go over 150 volts, let me back it off a little bit. 140. There we go. So now we've got it back down to 140. Let's give it a second to turn back on. There we go. Now we're pulling 9.2 amps. It's still at 1200 watts, by the way. It's still maxed out. But when we get higher, 42, 43, 44, 45, 46, 47, 49, drops to 0. You will notice my voltmeter here is a tiny bit low. It's saying 151 volts on the screen down here, 149 in my meter. So the power supply voltmeter is not all that good. But if you get above 150 volts, even a tiny, tiny bit, it's going to immediately stop pulling power to protect itself. So you want to keep a close eye on the open circuit voltage of your solar array. And if you have an array where your voltage at max power, which is always usually about 20% lower than your open circuit voltage, is 155 volts, your open circuit voltage is going to be too high. In the morning, when your panels come on, it starts at open circuit voltage before it pulls power. And then it starts pulling power and gets into voltage at max power where the voltage then drops. So if your panels have too high of an open circuit voltage, it's never even going to start charging because it'll detect the voltage is too high and then give up. So be very careful when you're building your solar arrays not to go over the voltage. But anywhere between, my voltage back down to about 130 here, anywhere between about 100 volts and 130-ish volts. That's the good working range for this device. So you really want panels in that range. 130 volts, now why not 150? Because panels make more power when it's below freezing. So if you're in an area that freezes, you're going to have some extra headroom because your panels will have higher voltage below freezing. So anywhere between about 100 volts and 130 volts, that's really your peak. That's where you want it to be. Now I've measured this. Here's a graph of this, and you can see the line jumping when I hit the 30 volt range. So that's expected as we just demonstrated with the meter. And that you can see that 100 volt range to 150 volt range is where it just kind of pegs up at the top. There are two charging modes built into the device. There's PV mode, and then there's other mode. And I showed you that earlier in the controls. The difference between the two is other mode artificially reduces the charging amperage during certain voltage ranges, specifically between about 50 volts through about 70 volts, roughly. It reduces your charging amperage back down to 8. And why is that? If you were to plug it into a Bluetti battery, where that battery is in power bank mode, the B230, the B300 batteries, those output in that voltage range, and they can't support 12 amps of output. So it is reducing the output down to what the batteries can handle, basically making it so that Bluetti stuff plays nice with other Bluetti stuff. So that's what happens in other mode. And if you forget and you leave it in another mode, and your solar panels are 55 volts, you're only going to be pulling 8 amps, and you're just going to be wasting power. So when you are running solar, make sure you put it in PV mode. And when you're running Bluetti stuff into Bluetti stuff, make sure you put it into other mode. In this particular case, it doesn't matter for car charging. It'll car charge either way. Maximum sound level test. So this is a test where the equipment that I have is going to be a bit of a challenge. So let me show you the test setup first. I have my fake solar up here. I have the settings in the menu. I have PV parallel turned on. That allows me to run this same power supply, which is a 5,000 watt power supply, by the way, to both inputs on the EP500Pro to max out the built-in solar. So let me go ahead and start turning this up. I'm at 2.5 volts here. I have to get above about 100 volts to max it out, as we saw earlier. 50 volts, 60 volts, 70 volts, 80 volts, 90 volts, 100 volts. And we're pulling 24 amps here because this is both solar inputs, so 12 amps times 2. And the noise, (64 decibels), that's all coming from this power supply. Nothing is coming from the EP500Pro yet. Turn on some load. Same loads we used earlier. Excuse me. Turn the AC side on. There we go. Still, the EP500Pro itself is not making noise. The noise you hear is coming from the DC power supply. And now the fan in the DC power supply is kicked on. So I don't think I'm going to be able to get a good reading here because my test equipment is too noisy. It has nothing to do with the EP500Pro. It's sitting here not making any noise at all. Let me turn off the fake solar here. We're all the way down to 46 decibels, which is really quiet considering this inverter is running at effectively max load. So it's quieter than my test gear. Let me put it that way. EP500Pro UPS mode testing. So the EP500Pro has, like many other Bluetti devices, an offline UPS built into it. What that means is that it will pass through grid power, assuming it's set to do so in the UPS modes. And if the power goes out, it'll immediately switch over to the battery. So let me show you how this test is set up, and then we'll go ahead and run it. So first off, you'll see I do have power right here running into the EP500Pro. That's coming from grid. Currently the power is turned off. I have two devices plugged in. The first is a 9-volt AC adapter. That's our test load where we're going to measure to see when it goes out. The second plug that's plugged in right here, this white one, this is plugged into the oscilloscope, and we're going to take a closer look at that in just a second. The 9-volt adapter that's plugged in down at the bottom of the EP500Pro is running into this load tester. The load tester is running at an entire 6 watts. not a very high load, but we actually don't need very much. The only reason we need the load tester at all is because otherwise the 9-volt adapter, which has capacitors in it, takes too long to finish discharging to trigger the oscilloscope. Second thing is I have a handheld oscilloscope here. This runs off a battery. At the top I have an attenuator. That's what my AC power is running into, is this attenuator. Don't ever run straight AC power directly into an oscilloscope unless you want to blow up your oscilloscope. You always have to run it through an attenuator. Next, after that, I have the other side. These two leads are running in parallel with the load tester on the output of the wall wart. The critical thing here, though, that you have to make sure if you're going to reproduce this, make sure the ground, also known as the neutral line, coming out of your AC line, is the same voltage as the negative side coming out of your AC adapter. Sometimes they are, sometimes they aren't. And if they aren't, this test won't work. All right, we're going to go ahead and run the test. So to start with, the EP500Pro is charging. The charging speed's set down to 5 amps, in other words, 600 watts. Just because in the case for this test, the speed at which it is charging does not matter. It simply matters that I pull the plug on it and measure how long it takes to switch over. The oscilloscope is in ready to go mode. And let's pull the power and then we'll measure how quickly it switched over. All right, let's throw the switch and see what we get. All right, there's a gnarly looking curve. Let's measure it. I'm going to measure here, turn the cursor to time. My A side, let's start about when the event started, right about there. And my B side, I'm going to go to where it started to recover. Right about there, plus or minus. So from A to B is 8.4 milliseconds. So why do I care about the number of milliseconds here? As you can see on the graph in this, turn the cursor back off here so we can actually see the line again. Set cursor to none. So we've got this nice regular incoming AC waveform. Then the power goes out. And then we get this nastiness in the middle. And then later we get a nice AC waveform coming out after it recovers. So the question is, how long is this in the middle? Most devices in the US can handle a downtime of about 20 milliseconds. So assuming this thing in the middle lasts less than 20 milliseconds, there's no problem. And in this particular case, it was 8 point something. Let me go back in there and turn my cursor back on so I can remember. 8.4 milliseconds. So that's well under the 20 millisecond requirement. So absolutely, it's going to work. Plug a computer into it, plug something else into it, anything you want, and it's just basically not going to notice that the power went out unless you have something incredibly sensitive, like, for example, an oscilloscope. So we have gotten to the end. EP500Pro, what do I think of it? Overall, the testing results show it to be nearly identical to the AC500 that I compared it to from a standpoint of efficiency, charging and discharging, solar input, all of that is nearly identical. So why would you want an EP500Pro versus an AC500? It really comes down to form factor. If you've got a single story house and you've got hard floors and you're going to be moving around the unit, the wheels are nice. It's easy to move around. The form factor, you can fit it in places where an AC500 wouldn't fit. AC500, of course, has those giant cables hanging off the side. EP500Pro is much more, shall we say, suave to the extent that any solar generator can be. As far as the testing, the only thing I was a little bit disappointed in was the USB 5 volt 3 amp ports. They really should have 3 amps per port, not 3 amps total. But honestly, I'm not that worried about it because if you're buying a unit that is this large in size to back up your entire house, the chance of you actually using those ports on a frequent basis is unlikely. And there are other USB ports on the same device, the quick charge ports and the USB-C ports, that just don't have that problem. So it is something to call out. It is something I noticed, but it is not something that I'm terribly worried about. Not really any sort of issue there. As far as pricing, there are deals to be had on this. It goes on sale pretty cheap, honestly, pretty frequently. In fact, the sale price on the EP500Pro is comparable to the sale price on a single B300S battery. So definitely deals to be had on this one if you're willing to wait for it and jump on the deals when you see them. So overall, very solid, very good unit. As always, I will call out that I am not paid to make these videos. This is a review unit that was provided by Bluetti. I simply don't have enough money to buy every solar generator out there in order to review them all. So they sent this out for me to take a look at. It was about 3 months, roughly, of testing to get all the data, and then this video gets put together. And after the video is done, this unit goes right back to Bluetti. So if you want to get into the review video market simply to get free solar generators, be aware that a lot of the time you actually have to send them back when you're done. You don't get to keep them. But they're not paying me to make the video. They don't get to see the video before it comes out. They have no idea what content is going to be in here. Very obviously, they don't get to tell me to change things. That wouldn't fly. But I don't get paid to make these, so I have no financial interest in them. And I won't. I make these because they're fun. And as long as you guys keep enjoying them, I will keep making them. So thank you all for coming this evening. Have fun.